Today, on how it's made. Giant valves. Sardines. Barographs. And disposable diapers. Valves control the flow of liquids and gases through pipes and tubes. They're so much part of our lives, we hardly think twice about them. But a faulty valve in an airplane or chemical plant could be catastrophic. Valves must be precision-made and trouble-free, whether it's small enough to fit inside the human body or as big as a car. Many gate valves use hand wheels to control the flow. Turning this wheel opens or closes a gate or wedge inside the valve body. This giant 10-ton gate valve works the same way. It will receive an internal gate or wedge that starts and stops the flow of liquids or gases. First, an automated horizontal boring mill prepares the valve body for assembly and for a controlling mechanism. It takes a controlling mechanism or motor, not a hand wheel, to open and close a wedge that weighs about 1,500 kilograms. An automated drill pilot drills the flange of the valve body. This centers the holes used for the bolts that will connect the valve cover. A technician double checks to make sure the holes are in the right place. Then an automated spade drill starts penetrating the flange. Coolant prevents the steel from heating up and removes steel chips from inside the perfectly centered holes. Meanwhile, the wedge is ready. A propane torch preheats the wedge for the plasma arc welding machine. This machine hard faces the sealing surface of the wedge, a process that ensures minimal wear. Hard facing creates 3 rows of weld beads, which will be machined smooth. Before installing the wedge, a technician inserts a seat ring into the valve body. A seat ring helps ensure a precision fit with the wedge. The ring fits into the grooved body cavity. Then the technician sets another seat ring in place. Before the wedge goes in, a semi-automatic welding machine welds the 2 seat rings into place using a rotating positioner. Then a lapping machine inserted into the valve body polishes each seat ring to guarantee their finish is flat and smooth. Next, a crane lowers the machined wedge into the body cavity. Using a gauge, a technician verifies the gap. He repeatedly checks to see what adjustments the wedge may need to ensure a tight shutoff. Another technician installs a sealer gasket to prepare the valve body for the cover or bonnet. Now he begins the final assembly. A fully adjusted wedge with a stem attached fits perfectly in between the 2 seat rings. This stem will connect to the controlling mechanism that opens and closes the valve. A crane lowers the bonnet with attached yoke assembly onto the body. Its studs fit exactly into the holes that were drilled into the valve's flange at the start. A technician readies all the bolts for machine tightening. Then he greases the top part of the stem. He lowers the controlling mechanism onto the stem and he screws it into place until it's flush with the yoke, the top part of the bonnet. A technician then bolts the controlling mechanism onto the yoke. Finally, another technician spray paints the fully assembled gate valve with a protective coat of corrosion-resistant paint. Precision-made gate valves are expertly crafted. They come in all shapes and sizes and are equipped with controlling mechanisms or hand wheels. From refineries and nuclear power plants to submarines and aircraft carriers, gate valves are helping our world run safely. The health benefits of eating fish are always under study. Today, it's said that most fish, like sardines, are a good source of vitamins, minerals, and omega-3 fatty acids. If you want to make healthy eating choices, you need to stay informed, so seeing how these little guys end up on your kitchen table is a good way to start. Sardines from the Pacific coastal waters off Costa Rica are freshly packaged in a variety of tasty flavors. It starts when sardines are put into a vat of icy water to keep them fresh. The temperature of the fish must be kept below 5 degrees Celsius to avoid spoiling. The fresh sardines then go through a machine that deposits them onto sorting lanes. Each lane allows a certain size fish to fall through the gap onto a chute below. Sorted as small, medium, or large, the fish drop into the proper container. Then workers load a specific size of sardine into a machine that removes the scales. Removing the scales takes 3 to 11 minutes, depending on the size of the fish. Once done, there's no mistaking a sardine with or without scales. Workers then place descaled sardines onto trays that take them into a cutting machine. They arrange the sardines on the trays in such a way that blades inside the machine will cut off the heads and tails. A look inside the cutting machine shows how it removes the heads and tails and sends them on their separate ways. It also cuts open and cleans out the bodies of the sardines and readies them for packing. The packing cans travel by conveyor to a workstation, with their bottom side up and open. They fill the cans manually to decrease the possibility of introducing foreign matter into them. The worker draws on his experience to estimate the required weight, then stuffs and trims the fish to fill the cans one by one. To be sure each can is exactly the right weight, he weighs and adjusts the amount in each tin. In only a matter of minutes, he completes a set of cans. Then another worker turns the set over and sends the open bottom cans into an oven that cooks the sardines at about 100 degrees Celsius. After cooking for about 25 minutes, a worker turns the set of cans over again and transfers them onto a conveyor system. All the cooked sardines gradually funnel into a single file, and, depending on the product, a filling machine treats them to oil or a specific flavor of tomato sauce. The filling machine overfills the cans with sauce, but a flute hidden inside the machine removes just enough sauce to put the lids on properly. The machine pressure seals the lids onto the cans so that when they exit the machine, they're airtight. The traveling cans then enter a machine that washes them in about 90 degrees Celsius water and makes them spotless. Pallets of cans then go into a chamber that sterilizes the product to keep it fresh. Then the cans go into a labeling machine that applies a thin coating of glue and pre-cut paper labels onto each one. The finished product comes out of the machine with an attractive full-color label ready to ship to the customer. Sardines come in a variety of flavors with easy-to-open packages that maintain the freshness of the fish. Ancient civilizations tried to forecast the weather by observing cloud patterns or even using astrology. Today, we rely on instruments like the barometer or the barograph, which automatically records on paper variations in atmospheric pressure. High pressure indicates good weather, low pressure means bad weather is likely. This barograph has three main parts: the recording arm, the cells that react to atmospheric pressure, and a rotating drum. To make the drum's lid, a die press operator stamps out a 9-centimeter disc from a long strip of brass. He cleans off the grease from the die press and places the disc on another press to form an edge. To make the drum, he cuts a 10-centimeter long cylinder from a brass tube. Next, he places the drum on an arm that rotates at high speed. He etches fine lines into the brass using steel wool. Thanks to a handy rotating device, all the drums get an even coating of protective lacquer so the brass doesn't corrode. The barograph's mechanism rests on a solid brass plate that's 214 millimeters long by 125 millimeters wide. A worker greases each one, then places them on a press that punches out holes for the fastening screws. Next, he places the plate in a metal holder and buffs it with a rotating polishing brush. He applies wax to the brush to help achieve a perfect mirror finish. Now, workers use a fine grade of sandpaper to polish the solid brass arms that will hold the working parts in place. Then they line them up on a board and buff them with the polishing brush. How do they get those parts so shiny? By washing off any machine grease before polishing them. Putting the barograph together is precision work. Laid out before the assembler are all the working parts she will need. She begins with an arm, inserts a brass screw, then sets in a second arm and attaches them to the base plate. These hollow metal cells are the key to the mechanism. Air pressure makes them expand and contract. The barograph records this movement to measure high and low pressure systems. The cell stack is put in place on the base plate. Then they add the lever system that connects the recording arm to the paper. This lever system connects to the arm, raising and lowering it so the felt pen at the tip can record changing air pressure levels on the drum's rotating chart. The assembler inserts tiny pins to hold it together. Inside the drum's base is a battery-driven quartz clock, which maintains a steady rate of rotation. Now she wraps the chart around the drum and attaches a brass clip to hold it in place. The drum rotates once over a 7-day period, so slowly that the movement is invisible to the naked eye. There's a gear system inside the drum, which rotates it once it's set on the axle. A brass screw holds it in place. Now the worker puts the mechanism on a mahogany base. She screws it into place, then covers it with a glass and mahogany housing. Brass hinges and a closing mechanism hold the housing firmly in place and provide easy access. A quality controller places the barograph into a pressure-sealed chamber to check its accuracy. He compares the barograph's recordings to gauges outside the chamber that measure the changes in air pressure that he applies inside the chamber. This weekly chart shows hour-by-hour recordings of air pressure variations measured in hectopascals, a unit of atmospheric pressure. Barographs are available in a variety of designs, from modern to traditional brass and mahogany models that any sailor would be proud to own. Parenthood has many joys, but a dirty diaper isn't one of them. And that's why we have disposable diapers. They were first introduced in the 1940s for travel use. It took several years for the idea to catch on, but when it did, diaper duty was never the same. Many would say disposable diapers represent a change for the better, helping parents make the best of a messy business. They start with superabsorbent polymer particles, which drop into a forming chamber. Pulp unwinds into the same chamber. A spray of water helps suppress any static electricity that could interfere with processing. Inside, the pulp mixes with the polymer particles. The result is this fluffy absorbent material that will be the diaper core. This rotating drum has a vacuum that shapes the fluffy material into padding. Another vacuum drum then merges the padding to a moving web of fabric. Guides fold the fabric around the padding, and a hot adhesive seals it. At this debulking station, rollers compress the padding, making the diaper core slim enough to comfortably fit a baby. A cylindrical cutter slices the diaper core to size. At another station, plastic film winds around guides and merges with another stream of fabric. Machinery glues the layers together to form the diaper's backside. Next, equipment pulls elastic bands into other layers of fabric to make leg cuffs and outer gathers on the top portion of the diaper. The elastic will ensure the diaper fits snugly, preventing leaks. Each diaper will be equipped with a set of these front tabs punched out by this rotating die. This cylinder applies stretch side panels to the top part of the diaper, which has the leg cuffs and gathers. The absorbent core now meets up with the backside of the diaper, and then the other layers come together and adhere. A computerized system monitors the assembly. Incredibly, it takes less than 1/4 of a second for all the layers of a disposable diaper to be assembled. The diapers now travel past guides that fold down the tabs and side panels. The diapers are then cut into individual units. Again, belted rollers compress the completed diapers. Paddles then fold them in half. Conveyor belts relay the folded diapers to a carousel. Finger paddles separate them and position them for packaging. Sensors count the diapers as they move towards compression arms that squeeze the required number together. A pusher swoops in to slide the diapers into a bag. Vacuum arms open the bags right on cue. Hot bars seal the package full of diapers. It then moves down the line to be packed into boxes for shipping. Each disposable diaper has a phenomenal capacity to absorb liquid, and the key is those polymer particles. They act as tiny gel sponges, expanding to hold many times their weight in fluid. Cut open a wet diaper, and you'll discover the liquid has turned the solid particles into gel. The proof is in the weighing. For example, this dry diaper comes in at about 45.5 grams. When it's wet, it weighs over 510 grams. And that's the bottom line.